Welcome to all. Myself Rajalakshmi, our Assistant Professor, Hindustan College of Engineering and Technology. I am going to present the topic inner product space. First, we have to take VBA vector space over the field F, where F is either field of real number or field of complex number. An inner product on V is a function from V cross V into F. If we saw what is inner product space, it's a function of mapping, which means domain will be V cross V and the codomain will be the field F and the function is inner product. For this function to be called an inner product, it must satisfy certain conditions. First one, linearity condition. Here we take addition of two vectors u1 and u2 and we take a vector space w from the second vector space v. It can be written as inner product of a u1 plus b u2 comma w equal to a into inner product of u1 comma w plus b into inner product of u2 comma w. For all u1, u2, w belongs to v and a comma b belongs to f. Next, symmetry. It's nothing but inner product of u comma v equal to inner product of v comma u, the whole bar conjugate. Whole bar. Conjugate means it's a complex conjugate. That means change the imaginary part sign. Last condition, positive definiteness. Inner product of u comma u is greater than or equal 0 for all u belongs to v and inner product of u comma u is equal to 0 if and only if u is equal to 0. Next, the definition about inner product space. A vector space with an inner product defined on its called an inner product space. If these conditions are satisfied, then that function can be called as a inner product. Next, let me explain through an example. Consider a vector space R power n. Let us define a function by inner product of u comma v equal to a1 b1 plus a2 b2 plus up to etc. an bn. Here u is equal to a1 a2 up to etc. an and v is equal to b1 b2 up to etc. bn. Now I am going to check the above defined function is an inner product or not. By checking the above three properties, linearity, symmetry, positive definiteness. First one, linearity. That is, inner product of alpha u plus beta v comma w equal to alpha into inner product of u comma w plus beta into inner product of v comma w. Consider the LHS inner product of alpha u plus beta v comma w equal to inner product of alpha into a1, a2 up to etc. an plus beta into b1, b2 up to etc. bn, comma w. Next, using the normal multiplication and collecting each components. That's equal to inner product of alpha a1 plus beta b1 plus alpha a2 plus beta b2 plus up to etc. alpha an plus beta bn, comma w. Again by definition, alpha a1 into c1 plus alpha a2 into c2 plus up to etc. alpha an into cn plus beta b1 into c1 plus beta b2 into c2 up to etc. beta bn into cn. Next, using the multiplication, collecting the alpha terms and beta terms separately, which gives alpha into a1 c1 plus a2 c2 up to etc. an cn plus beta into b1 c1 plus b2 c2 plus up to etc. bn cn, which is equal to, again by definition, inner product of alpha u plus beta v comma w equal to alpha into inner product of u comma w plus beta into inner product of v comma w. The above functions satisfy linearity. Secondly, we need to check symmetry. Consider the LHS inner product of u comma v equal to a1 b1 plus a2 b2 up to etc. an bn. Here the multiplication of the scalars are commutative. AB is nothing but BA. So that we can rewrite B1 A1 plus B2 A2 plus up to etc. BN AN, which is equal to inner product of V comma U. Therefore, symmetry conditions are also satisfied. Next, we need to check positive definiteness. For any u is equal to a1, a2, etc. an belongs to r power n. U not equal to 0. We have inner product of u comma u is greater than or equal to 0. Thus, the given function is an inner product on r power n. Hence, r power n is an inner product space for the defined product. Consider the another example. Let inner product be the standard inner product on R square. If U is equal to 1, 2, V is equal to minus 1, 1 belongs to R square. Then find W belongs to R square. Satisfying inner product of U, W is equal minus 1 and inner product of V, W is equal to 3. Let us consider the solution is let us consider W is equal to A, B belongs to R square. Given the conditions, inner product of u comma w is equal minus 1 and inner product of v comma w is equal to 3. Using the inner product, we get the two equations a plus 2b is equal minus 1 and the another equation minus a plus b is equal to 3. So, solving these two equations, we may get the value a is equal to minus 7 by 3 and b is equal to 2 by 3. Therefore, w is equal to minus 7 by 3 comma 2 by 3. Next, the definition about norm. Let V be a vector space and let U belongs to V. The norm or length of U is denoted by norm U is equal to square root of inner product of U comma U. Here note is norm U is equal to 1 where U is called a unit vector. Next, now let me define angle between two vectors. The definition about angle between two vectors, let V be an inner product space and V be two non-zero vectors in V. The angle between U and V is defined to be the angle theta. The theta is lies between 0 to pi. Then the formula is cos theta is equal to inner product of U comma V divided by norm U into norm V. Next, let us find angle between two vectors through an example. R power 3 is an inner product space with respect to standard inner product. Find the angle between the vector u is equal to 1, 1, 2 and v is equal to 2, minus 1, 1. The solution is, we know that the formula already cos theta is equal to inner product of u comma v divided by norm u into norm v. Then we need to find inner product of u comma v and norm u and norm v. Using the inner product and norm, we got the values inner product of u comma v equal to 3 and norm u is equal to root 6 and norm v is equal to root 6. After substitution, cos theta is equal to 1 by 2. Finally, we get the value theta is equal to pi by 3. Next example 2. In the inner product space R power 4 with respect to standard inner product, find the angle between the vectors u is equal to 2, 1, 2, minus 3 and v is equal to minus 2, 2, 1, 3. Here already given u and v values. Next we need to find inner product of u comma v and norm u and norm v. So, using the inner product and the norm, we got the values inner product of u comma v is equal to minus 9 and norm u is equal to 3 root 2 and norm v is equal to 3 root 2. So, after substitution, cos theta is equal to minus 1 by 2. Finally, we get the value theta is equal to 2 pi by 3. Thank you.